good. Okay, so here's our next one. So in nitryl chloride, there is no oxygen-oxygen bond. Write a Lewis structure for the molecule and write any resonance structure. So there's no oxygen-oxygen bond, which basically tells us that nitrogen, so just counting up valence, but nitrogen's likely the center. So we've got 5 valence here. We've got, for oxygen, we've got 6 times 2, which equals 12. So 2 for the 2 oxygen molecules, and chlorine will have 7. So summing these up, we get 24 valence. Okay, so then trying to do this in kind of an easy way first by using the normal valence. And oxygen, and then chlorine. Okay, so we can connect this, we can connect this, we can connect this. And if we look, we've got a full octet here, and we've got a full octet here, but then these guys here are not full and not full. So the easiest thing to do would be then to move an electron over here and use this guy and this guy to form a bond, as that way we'll keep our octets, but then we'll see what comes of that. So if we redraw that, we've got this with a double bond to oxygen and chlorine. And now if we count up so now we see that everyone has a full octet. If we count up our electrons around each of the species, we have 1, 2, 3, 4, 5, 6, 7. So we only take half of so there's 2 electrons on a bond, we only take half of that for how many is actually around it. So there's 7 electrons here, which means this guy has a 1 minus charge because there's 1 extra. And here we have 4 electrons, so we have a 1 plus charge because there's 1 too little. Here we have 6 electrons, so that's neutral. And here we have 7 electrons, so that's also neutral. So we've got a structure here where there's only 3 bonding partners, so it'll be a trigonoplanar molecule. So drawing it now with a bit more structure. And so now we have full octet everywhere, but our charges are separated. So we've got a plus charge on the nitrogen, a minus charge on the oxygen. But also we have some resonance possibility because this could happen to give us a very similar structure. Where now the negative charge is over here. Positive charge is still on the nitrogen. And now, so the negative charge is actually shared among the oxygens, which helps to stabilize the structure. Okay. And so that's it, that's the final structure for our nitryl chloride. So we counted up 24 valence electrons. I didn't ever check it, but I'm pretty sure all 24 are there. And how do we get, I guess I wouldn't say we would be able to get that resonance structure, but that one's a bit far-fetched on the left, because now nitrogen has 5 bonds, which is a bit out of this world for nitrogen. For the species beyond nitrogen, it's fine, but I would say nitrogen wouldn't be too happy with it. So I think I'm happy with the two that I've drawn, but I guess technically that one is a resonance structure, but I would go with the two I've drawn. So that's it. Solution is correct. 5 bonds.